chain rule itself sounds scaring. Undoing chain rule might sound even more scaring, but you see that it is not. Let us remember what the chain rule told us. And we are going to work with functions of the type f of x equals x to the power of n, where n is a real number and is not minus 1. Remember from the previous lesson. So, what if now, remember that integral x to the power of n dn, x to the power of n dx, was x to the power of n plus 1 over n plus 1 plus c, where c is any real number. And now you see why n cannot be minus 1. What if we had to differentiate a function like 2x plus 1 to the power of 3? If we want to differentiate it, remember it was 2x plus 1 squared times the derivative of 2x plus 1. So, we can write that, which is 6 2x plus 1 squared. So, integral 2x plus 1 squared dx is going to be 1 over 6 brackets 2x plus 1 cubed plus c. Remember, when we integrated only x squared dx, we got 1 over 3 x cubed plus c. But here we have a times 1 over 2 from the derivative of 2x plus 1. Let us take another example. Integral 7x plus 3 to the power of 4 dx. Now, if we differentiate 7x plus 3 to the power of 5, right, we get 5 bracket 7x plus 3 to the power of 4 times the derivative of 7x plus 3, which is 7. Therefore, when we differentiate 7x plus 3 to the power of 5, we get 5, so we need to cancel that 5. And also we get a times 7 from the chain rule, so we need to divide by 7 here as well to get our answer. As a conclusion, we get the formula integral ax plus b to the power of n dx is ax plus b to the power of n plus 1 over n plus 1 times a plus c, which is of course undoing the rule. The derivative of ax plus b to the power of n is n times ax plus b to the power of, let us take n plus 1 here, change a bit, n plus 1 to the power of n times a. Now you see why I need to divide by this a here. The method before was an intuitive one. We just look at the integral, like for example integral 3x minus 7 to the power of 4, and we think that it comes from 3x to the power minus 7 to the power of 5. But when I differentiate this, I get a 5, so I need to divide by it, and then I get a 3 from the chain rule. Let me show you another method to solve such kind of equation. So it's just the same thing, just another way of writing it and thinking of it. And this is called integration by substitution. You'll learn more about it in year 12, both in high level and standard level courses. But sometimes it looks easier. So you just look and you choose whatever of the two methods you want. Maybe you want to try a couple of examples with both methods, The first one, let's call it by inspection, and the second one is by substitution. So let's do the integration by substitution. If I take the same integral 3x minus 7 to the power of 4 dx, I'm thinking that it looks like, and I would like to use the rule integral x to the power of n dx, which I know that x to the power of n plus 1 over n plus 1 plus c. But I don't have x to the power of n. I have a composite function. So I will say let u be 3x minus 7. Right? So my integral will become integral u to the power of 4. I just replace dx. Now I cannot have u and dx. I need to have here du. How do I get this one? Look at my substitution. U equals 3x minus 7. Therefore, du by dx equals 3. So though this is not a fraction line, yes, I can treat it like this and think that this is the same as du, and it's correct to write like this, equals 3 dx. So if I move into my integral, and I replace, is going to be integral u to the power of 4 times, and dx from this equation is 1 over 3 du. So this is 1 over 3 integral u to the power of 4, which is u to the power of 5 over 5 plus c. And now the next step is just to replace u by 3x minus 7. So it's 3x minus 7 to the power of 5 over 3 times 5 plus c. And that's integration by substitution. I substitute 3x minus 7 by u. Let me take another example and solve it by substitution. Integral 3 over square root of 5 minus 4x to the power of 3 dx. I repeat, if you are okay with the previous method, then just forget about it. You know, see, I have a composite function, so I will let 5 minus 4x equals u. Therefore, du by dx equals minus 4. So du equals minus 4 dx. Now if I replace, I get integral 3 over square root of u times dx, and remember dx is minus 1 over 4 du. So this is minus 3 over 4 integral 1 over square root of u du. So it's minus 3 over 4 integral u to the power of minus 1 over 2 du, which is minus 3 over 4 u to the power of negative 1 over 2 plus 1 over negative 1 over 2 plus 1 plus c. So it's negative 3 over 4 times 2 over 1 from the denominator times u to the power of 1 over 2 plus c. And now I cannot leave it in terms of u because I was asked about x. So first of all, the coefficient is minus 3 over 2, and now my u was 5 minus 4x to the power of 1 over 2. I can leave it to the power of 1 over 2, so, or I can write it square root of 5 minus 4x plus c. Let us look at an example of integration with some parameters. So find integral the mth root f px plus q dx, where m, p, q are constants. Let u be px plus q. Therefore, du by dx equals p. So du equals p dx. Replacing, I get integral mth root of u times 1 over p du. So it times 1 over p, sorry. So it's 1 over p integral u to the power of 1 over m du. 1 over p u to the power of 1 over m plus 1 over 1 over m plus 1 plus c. So this is m over p brackets 1 plus m. See, this part is m plus 1 over m times u to the power of m plus 1 over m plus c. And now I just replace u in terms of x, so it's m over p brackets 1 plus m px plus q to the power of m plus 1 over m plus c.